Next, we're going to do another application that involves exponential functions, and it's called compound interest. So first of all, we're going to review the interest problems that we're used to doing, and these are actually computations where the interest is computed every year. We're going to think about how to compute interest if interest is computed more than once per year. And then we're going to find the formula for compound interest and do an example. So recall the in-class activity where we started with $1,000 and each year we earned 5% interest. That was called our annual interest rate because we earned that 5% every once per year. So every year, it turns out we multiplied by the amount of money in our account by 1 plus 0.05. We had the money that we originally had plus 0.05 times that money. Once we factored out the money, we ended up multiplying it by 1 plus 0.05. And so that gives us 1.05. Now, if the amount of money at time t is a of t, well, we know that a of 0 equals 100. We know that a of 1 equals 1,000 times that 1.05. Now, if we want to get from a1 to a of 2, 1 year to 2 years, we're going to take that amount of money that we have, that 1,000 times 1.05, and multiply that by 1.05. Right? And that gives us 1,000 times 1.05 squared. If we want to get from 2 years to 3 years, we're going to take that 1,000 times 1.05 squared and multiply it by 1.05. And then we end up with 1,000 times 1.05 to the third. In general, if you can see the pattern developing, we're going to end up with a of t equals 1,000 times 1.05 to the t. And again, t is given in years. So in general, if r is the annual interest rate and a0 is the amount of money at t equals 0, then we get a of t equals a0 times 1 plus r to the t. Every time we go from one amount to the next in successive years, we always multiply by 1 plus r. So now the question is, how do we compute interest if we do it more than once per year? Right? Because this was contingent upon we compute interest once per year. So we get what's called compound interest. That's what happens when we compute interest more than once per year. And so let's say we're in a situation where we invest $1,000 in an account that earns an annual interest rate of 5% compounded 4 times per year. Now I do want to stress that 5% is annual, which means it sort of represents the interest that we earn over the course of a year. Right? Now, and the fact that we're compounding it 4 times a year, that's just a fancy word by saying we compute the interest 4 times per year or once every 3 months. So at time 0, we have 1,000. So the question is, what should we have after a fourth of a year? Well, remember, 5% is the annual interest rate, so we shouldn't get 5% of 1,000 after only a fourth of a year, because a fourth of the year is only a fourth of the year, of the annual time period. So definitely should not earn 5% interest in the first 1/4 of the year. In fact, what we should do is we should earn a fourth of that interest in the first 3 months, which means over the course of that first 3 months, we should earn an interest rate of 0.05%. And if we want that in decimal form, that's 1.25%, which is 0.0125 if we're thinking of it as a fraction. Which means that every 1/4 of a year, we're earning 0.05% interest, which means we're going to multiply by 1 plus 0.0125, which of course is 1.0125. So if we want to find a of 1/4, that is going to be, if we can do this the old-fashioned way, just take that 1,000, add 1,000 times 0.0125. When we factor out that 1,000, we multiply that by 1 plus 0.0125, which is 1,000 times 1.0125. After a half year, we're going to take that 1,000 times 1.0125, multiply that by 1.0125, because we're earning 1.25% interest, and then we end up with 1,000 times 1.0125 to the 2 power. after the 3/4 of a year, we're going to take that 1,000 times 1.0125 squared, multiply that by 1.0125, and we end up with 1,000 times 1.0125 to the third power. And then the same thing happens after 1 year. That's 4 times it gets compounded. We take what we previously had, multiply that by 1.0125, and we end up with 1,000 times 1.0125 to the fourth power. Now, we'll use a little bit of imagination to see what happens when we get to 2 years. We're going to go through that process 4 times again. Each time, 1 1/4, 1 1/2, 1 3/4, and then 2. Each time we're going to multiply by 1.0125. To get from 1 to 2, we're going to have to do that 4 times. So we're going to multiply by 4 factors of 1.0125, which means we're going to end up with 4 more factors, 1,000 times 1.0125 to the 8th. We did have to the 4th power. We're gaining 4 factors. That means we're going to end up at the 8th power. For the 3rd year, we're going to add on 4 more factors of 1.0125 to get 1,000 times 1.0125 to the 12th. After 4, we're going to add on 4 more factors to get 1,000 times 1.0125 to the 16th. I'm sure you can see the pattern here. After t years, we're going to end up with 1,000 times 1.05 to the, well, each time, whatever our time is, we seem to be multiplying by 4 to get the exponent. So if our input is t, our output is going to be 4 times t. All right, so this is our formula for compounding it 4 times. Notice that after 1 year, we're going to have a of 1 equals 1,000 times 1.0125 to the 4th power, which is about, a little over 1,050.95 The interest that we earned on that $1,000 is $50.95, of course. Just as a neat little fact there, if we just compound it once at the end of the year, 5% of 1,000 is $50, which is significantly less than that 50.95. Not much less, right? Just an extra 95 cents. But the idea is when you compound interest, you earn more money. Now, in general, suppose you start with an investment A0, so that's your initial amount of money that you have, and your annual interest rate is R. And R is given, in this case, as a fraction, not as a percent. So if you're at 5%, your R is going to be 0.05. If you're at 1%, your R is going to be 0.01. Suppose we compound our interest n times per year. Well, this is going to take a little bit of imagination, but based on our previous experience, I think you can handle it. So what kind of interest rate do we get each time the interest is compounded? Well, every time the interest is compounded, we do it n times per year. Each time period is going to be 1/n of a time per year. So if we're taking 1/n of a time per year, the interest rate we should get is 1/n of the annual interest rate. So we should get R over n as our interest rate over that compounding interest period. Each time we compute the interest, what we're going to take is whatever we had before we computed that interest and multiply that by 1 plus R over n. Remember, R over n is the fraction form of the interest rate that we're earning. 1 plus that is what we multiply by to get the next amount of money. And each year we're going to multiply by that 1 plus R over n a total of n times, because that's how many times we're compounding the interest in a year. So that means every year we're going to be multiplying by 1 plus R over n to the nth power. So after 1 year, we're going to be multiplying our money times 1 plus R over n to the n. After 2 years, we're going to do twice that, 1 plus R over n to the 2n, etc. So if we have a of t equals a, in general, is going to be a0, we are going to take our 1 plus Rn, we're going to multiply that by n times, or 1 plus R over n times during each year. If we go over t years, that's a total of n times t times. All right, so now let's suppose we have a $500 that we're investing in an account that earns 3% interest yearly, that is compounded every 2 months. Assuming we make no deposits, how much money do we have in the account after 10 years? Now, since we're compounding every 2 months, that means interest is going to be computing 6 times per year. That means our n is equal to 6. N was the number of times per year that we computed our interest. So our interest rate for each computation, well, it's 3% over the course of a year. It's going to be 3 over 6%, which is, when we turn that into a fraction, is 0.005. Which means that every year we're going to every time we compound our interest, we're going to multiply by 1.005. Since every year we compound it 6 times, we're actually going to be multiplying by 1.005 to the 6th every year that passes. So A0 is going to be 500, and that means our A of t is going to be that 500 times 1.005 to the 6t power. So if we want to figure out what's going to happen after 10 years, we just have to plug in t equals 10. A of 10 is equal to 500 times 1.005 to the 6 times 10. If we let our calculators or Desmos or Wolfram Alpha take care of that, that's going to be about $674.43. All right, so now after this, I think you're ready to work on the in-class activities. The name of the PDF with this video is called Compound Interest.